Good morning.
Good morning.
Can you see me and hear me well?
Yeah.
Yes.
People are appearing here on my, actually their names are appearing slowly on my screen. I have quite important announcement for today. Today is quite nice sunny day, at least in my part of Bay Area. What about yours? I live in Sunset in San Francisco. We quite rarely have nice days here, but today is a really nice day. Okay. I think we have quite enough people to talk about this announcement. As you know, you will have a quiz today. It will be at the end of our class. It will start for you at 11:30. But up to 11:30, we will be talking about trigonometry. And today we will not have our 5 minutes break because we need to cover many methods and to show how to apply that formulas, which we already learned. We are equipped by so many formulas. So, and to remind everyone, I would like to say that our last theoretical topic was about double angles and half angles of trigonometric functions, with trigonometric functions of double angles actually and half angles. If you are ready, I can start. I'm grabbing the textbook. Let me see what I already did. I think we solved quite long problem on page 237, which had, it was problem number 8. It had part A, B, C, and D. And here I will show you that piece of paper. So can you find same thing on your notes? In your notes?
Yeah.
Okay. So again, it was from page 237. I will now move to page 236, but I will later come back to page 237 to show you more problems from that page. Right on the top of page number 238, we have a problem numbers from 47 to 68, and this is about establishing each identity. This is actually the part of that assignment where we need to prove establishing identity, which means you can here in the textbook establish the given identity or verify or just simply prove identity. These are all identity type of requests. So let's say we will start with problem number 47. Are you okay with that?
Yeah.
Okay, and here again, I discovered here a paper where I had all these formulas. You should have all these formulas in your notes because we talked about that. So I'm going to right now start that problem. Let me grab my pen and I'm starting. First, I will copy that problem, page 238. Problem number 47, which is cosine to the 4th power of x minus sine of 4th power of x is equal to cosine of 2 theta. Cosine to the 4th power of x minus sine to the 4th power of x. Oh, sorry. Look what I did. I wrote x on one side. I really apologize. I really apologize. Please change everything to theta. Cosine to the 4th power of theta minus sine to the 4th power of theta should be equal to cosine of 2 theta. I don't think that right now in our group of people, we have people who can say that here, left side looks easier than the right side. Because
I think so.
we have 4th powers. They agree with me.
Yep.
Why am I comparing actually these two sides? Because if you remember, my recommendation was try to start with that side, which looks more complicated. Do you remember that?
Yes.
Yeah.
So this one, it looks natural that we will start with the left side. So write down LS, and let's see what we have on this left side. Can I say that we have on the left a difference of 2 4th powers?
Yep.
Another statement, can I say that 4th power is the square of square?
Yes.
And look what I'm going to do. I will write something here on the side of that problem, which is not a part of it's this own problem, but it will be very connected to what we need to do in this problem. I'm going to write a to the 4th minus b to the 4th power, and I'm writing, like we said, square of a squared minus b squared of squared. So this is what I wrote on the side. A to the 4th minus b to the power equals a squared squared minus b squared squared. Are you okay with that?
Yeah.
No?
Yeah.
Yeah.
Excellent. And now let's precisely look at this part. A squared squared minus b squared squared. Is it the difference of 2 squares?
Mm-hmm.
We have a formula for the difference of 2 squares, which is a squared minus b squared equals parenthesis a plus b times a minus b. This time, instead of a, we have a squared. Instead of b, we have b squared, but we can apply that formula. This why we can factor it as a squared plus b squared times a squared minus b squared. Why? Because I applied difference of 2 squares formula. A squared plus b squared times a squared minus b squared. Can I continue?
Mm-hmm.
And this, what I'm going to do, I'm going to right now apply this part to what I had on the left side in given problem. This why I will be treating cosine to the 4th theta like a to the 4th, and sine to the 4th power of theta like b to the 4th power. This why I can factor this left side as in that factor form on the left, on the right side where we had this in terms of a squared and b squared, I will be writing here in terms of cosine and sine. So it will be cosine to the 2nd power of theta plus sine to the 2nd power of theta. In other words, cosine squared theta plus sine squared theta times another parenthesis cosine squared theta minus sine squared theta. Cosine squared theta plus sine squared theta in third parenthesis, cosine squared theta minus sine squared theta in the second. So far, so good?
Yeah.
Can you please look at the first spot, first parenthesis? What do we have here? We have cosine square of theta plus sine of square of the same angle theta. Is it equal trigonometrically to 1?
Yes.
Right? Only one student is okay.
Yeah.
Yes.
Yeah.
This is the formula. Sine squared theta plus cosine squared theta equal to 1. If we like, we can write the same formula like cosine squared theta plus sine squared theta equal to 1. And look what I did. I wrote on the bottom of that this is equal to 1. This y, I can replace that first spot by 1 because it is equal to 1. And this what we have. 1 times cosine squared theta minus sine squared theta. 1 times cosine squared theta minus.
Clean runs. Clean run. Clean run.
But I will be dropping that 1 right now. And I'm left with cosine squared theta minus sine squared theta. Do you have any formula which we just covered recently where we have this expression cosine squared theta minus sine squared theta?
Formula number 2.
Is it the cosine of double angle?
Yeah.
What is the ordinary angle? Is it theta?
Yep.
What would be double angle? 2 theta, right?
Mm-hmm.
Which means, as a result of applying these steps, we came to cosine of 2 theta. Should we stop saying that we actually are done? Are we done with our proof?
Yeah.
Or place that small square, which means the end of proof. Definitely we proved this identity. We definitely proved this identity. Can I move to another problem with your permission?
Yep.
Okay, let's do that. Same page. I really like to solve another problem from this spot. What do you think about problem number 57?
Yeah.
Sounds good.
So can I start with that problem?
Yeah.
Number 57?
Yes.
Mm-hmm.
Why did I choose that? Because it had secants. 57. What do we have here? Secant square theta over 2 equals 2 over 1 plus cosine theta. This is that problem. Secant square theta over 2 equals 2, 1 plus cosine theta. Sunlight is so bright that screen of my laptop is quite dark. Can you see well what I show on this paper?
You can see it.
I'm happy. One side has really not our most preferable function, secants. We more like to work with sine, cosine, and maybe tangent, but secants does not, we cannot include secants in that group. but we have secant square of theta over 2, not even theta, it is half of the theta. On the other side, we have a fraction. On the top, we have 2, on the bottom, we have 1 plus cosine theta. According to your opinion, which side looks less desirable than the other one?
Last one.
The left?
Left? Okay, I think so. From the student's point of view, yes. Because I have different perceptions, you need to remember that I am a professional mathematician, and definitely I, like a chess player, already can see how this, let's say, problem should be solved, seeing already in my mind several steps ahead. But I would do what you just said. I will start with the left side. Left side. As any normal student would probably do, you would try to get rid of secants. Is it true?
Yes.
Which function is a very close relative for that function? For secants.
Cosine.
I agree. So, but I have here secant squared of theta over 2. Can I replace that by 1 over cosine square of theta over 2?
Yeah.
Yep.
Definitely we can. Because in the first power, they are reciprocals, which means in any other power, there also will be reciprocals. And look what I wrote. I wrote that it is equal to, left side equals to 1 over cosine square theta over 2. And I showed you so many different formulas. Can you look at the formula number 7? Formula number 7 from last time lecture. Does it have cosine square of alpha over 2?
Yep.
Only instead of alpha, you need to have your theta, and the rest will be in terms of theta. So I'm going to use that formula number 7 right now. So, which means it will be 1 divided by the fraction 1 plus cosine theta, not theta over 2 anymore, divided by 2. This is what I am getting applying formula number 7. And after that, I will just use algebra. It will be 1 times reciprocal of that fraction which I had on the bottom. This is what I'm getting. 1 times this fraction equals to that fraction, which is 2 over 1 plus cosine theta. Are we done with the proof?
Yep.
Yes, we are. And voila, this is what you have.
I have a question.
Yeah.
What would you have done if you started with the right side first?
With the right side, it is not in the form matching formula number 7. I would rewrite this like 1 over that fraction. Basically, look at what we did right now, starting with left side and start with the end and go to the beginning. So starting with the last one, you can just go in opposite direction and it will be your proof from right to left.
Okay.
Did I answer your question?
Yeah.
No, feel absolutely free to ask, because right now I'm here to teach you and to release you from possible confusions, guys. There is nothing wrong to ask You know what, you already should know my character. I will never ignore any request to, you know what, to give additional detail or to explain this again. My eyes caught another problem, and this time it is number 62. Does it look nasty enough to be solved right now? I'm talking, you understand what I mean saying nasty enough, because I discovered here cubes. I'm trying to look for some different powers. Can I?
Yeah.
Yep.
Yes.
Okay, write down number 62. Number 62, and I'm going to copy this right now, and please do the same thing. 1/2 sine 2 theta should be equal to that fraction, sine cubed of theta cosine cubed, and downstairs sine theta plus cosine theta. This is that particular problem. Which side you like less than the other one?
The right side.
Is it just Jessica's? This was Jessica's voice, right?
Yeah.
Yeah, I remember your voices. Okay, is it just Jessica's opinion?
You do the right side.
The right side. So two.
Let's start with the right side. And let's analyze what we have here. We have cube plus cube. This is not a secret that when we work with trigonometry, we use actively algebra, because trigonometry is another algebraic subject. Only it is as an algebra of specific type of functions. You know what? In some countries, they even do not call this class like trigonometry or textbooks. They call them algebra of trigonometric functions. But it is normal to call it trigonometry. I like when it has its own specific name. But here we need to remember everything what we learned in algebra. In algebra, a long time ago, it was in Algebra 1. In our college, it is elementary algebra course. I think it is Math 110. You learned formula for a cubed plus b cubed. Do you remember this formula? I am writing this on the side. I am talking about this formula, a cubed plus b cubed. Do you have any brave person right now who can help me with that formula? Or just tell me that my help is desperately needed.
Is it parentheses a plus b?
Sounds good so far. A plus b, I'm writing this down.
And then another parentheses,
I opened already.
a squared minus ab plus b.
One second, please.
Sorry, someone's like mowing
Yes,
behind
a little bit slower for a little bit slower for other students. They need to follow that. I already wrote it down in parentheses. A plus b closed. Opened another parenthesis. Okay, can you please?
A squared
minus
ab plus b squared.
Perfect. Good girl. Not even good girl. The best girl on the planet, maybe even in universe. Good. I showered you with compliments. Yes. This is that formula. A cubed plus b cubed equals a plus b, parenthesis, a squared minus ab plus b squared. Now, we will apply that formula, but we will treat a as sine of theta in the first power, and b will be our cosine of theta in the first power. So practically what we have on the right side in our identity, it is on the top a cube plus b cube, and we can factor it according to the formula which we just remind ourselves from algebra. So it will be a is sine theta, so it will be parenthesis sine in the first power of theta plus cosine also in the first power, close parenthesis, open new set of parentheses, and it will be a squared, which is sine squared of theta, minus ab, which is sine theta, times cosine theta, and finally plus b squared, which is cosine squared theta. On the bottom, just copy what you had. Sine theta plus cosine theta. And this is what you are getting. Sine theta plus cosine theta times sine squared theta minus sine theta times cosine theta plus cosine squared theta. Can we cancel this algebraic fraction? Yes, we can. We will not be canceling sine with sine, cosine with cosine, because it is illegal. Sine theta plus cosine theta is a solid piece. We cannot partially cancel this with any other expression, but we cancel entire thing, entire sum of sine theta plus cosine theta, because we have absolutely matching piece in the denominator of that algebraic fraction. Cross them out. Sum of sine and cosine of theta with another sum of sine and cosine of theta. What we are left with? On the bottom, we have 1. On the top, we are left with that second parenthesis, which is sine squared theta minus sine theta times cosine theta. This is quite nice, interesting problem, actually. This, what we have, no fraction anymore. No fraction. And I'm going to play a little bit with these terms, maybe combining some of them in one group. Why? Because what I see here, I see second power of sine, second power of cosine, and the product of first powers of sine and cosine. I'm going to unite together that second powers, sine squared theta plus cosine squared theta in one group. And this is standing separately. I'm talking about the product of sine and cosine. This is what I did. Can you look precisely at that parenthesis which you can see on that screen? Can we replace this by anything? Does any trigonometric formula come?
1.
Definitely, it is 1. It is 1. Now, look precisely at sine theta times cosine theta. We have a formula for that, but it is in 3.7. So this is why we will not be using that. But we already covered certain formula, which does not exactly look like this one, but some part of that formula matches that type of product. Can you please can you please precisely look at formula number 1, which is for sine of double angle? Does it have sine theta times cosine theta?
Yes.
But it has coefficient 2. because sine of 2 theta equals 2 sine theta times cosine theta. And here we do not have this one. But I'm going to write this again on the side. I'm talking about formula number 1. So sine of 2 theta equals 2 times sine of theta times cosine theta. This is what I wrote here on the side. And seeing here sine theta times cosine theta, let's say I decided to solve this for sine theta times cosine theta. Can I divide both sides by 2?
Yes.
Yes.
Let's do that. Divide one side by 2, divide another side by 2. Cancel 2's on the right, and you are getting sine theta times cosine theta equals sine of 2 theta over 2, right? That sine theta, 2 theta over 2, division by 2, dividing by 2 can be replaced by multiplication by 1/2. Do you agree?
Yes.
So which means I'm writing or sine theta times cosine theta equals 1/2 of sine of 2 theta. I use simple algebra, replacing division by 2 by multiplication by 1/2. So, and now I have here an expression which can be used to replace sine theta times cosine theta. Can I replace that by 1/2 of sine of 2 theta?
Yeah.
Yes.
So let's do that. So it will be, I'm going back to the problem. So I already wrote 1 minus. Now I'm continuing. It is 1/2 times sine theta, or sine theta, I said sine of 2 theta, because I replaced sine theta times cosine theta by its equal expression, which is 1/2 of sine of 2 theta. And now what I discovered, that what I got right now is absolutely identical to what I had in the given problem on the left side. Do you agree with me?
Yes.
And I'm done with this problem. You can see here, I applied a formula from algebra, and I applied not even one, but at least one when we replaced sine squared theta plus cosine squared theta by 1. And after that, we used formula for the sine of 2 theta. So I here used and algebra, and I used here and trigonometry to prove this identity. And this is quite typical for our subject, for trigonometry, because it widely uses both and algebra and trigonometry to prove identities or to solve equations and etc. So, do you want one more identity, or I can move to equations?
You can move to equations.
Okay, let's move to equations. Definitely, it would be very nice to solve more and more and more problems, specifically when you do that under my supervision, when we work together. But unfortunately, this is a luxury which we cannot afford, unfortunately, anytime, even during regular lectures when we have face-to-face classes. And right now, when we had such a horrible circumstances, and we missed one day in March, and 1 day for you is equivalent to 2 hours. It is a lot. So let's now move to equations. Equations here are from problem number 69 to problem number 78. And these are equations where you can see we have here double thetas, and we can have thetas. So basically, if we talk about double theta, 2 theta, it is double angle with respect to theta. If we talk about theta, I can say that theta is a half angle for 2 theta, because theta is 2 times smaller than 2 theta. So we can say it is a half, theta is a half angle for 2 theta. So basically, which means you maybe will be forced to use any formula which we covered in this section. Which of these problems you like to see right now? They are quite close to each other. 69 or 70?
$70.
Okay, 70. In problems from 69 to 78, solve each equation on the interval from 0 to 2 pi. Okay, I will copy cosine of 2 theta equals 2 minus 2 sine squared theta. And please copy that restriction for theta. It is between 0 and 2 pi, or in other words, your theta belongs to semi-closed interval from 0 to 2 pi. And precisely look at 2 sides of this equation. Anytime when you solve any equation, my recommendation is ask yourself some questions. Question number 1. On both sides, do we have same angles or different?
Different?
You say different? Yes. This is why you need to try to use certain formulas to get same angles on both sides. One thing. After you do that, you need to ask yourself if you have these angles under symbol of the same functions. If you have same angles under symbols of the same trigonometric functions, your situation will be much easier than if you do not have it. So here we have, on the left side, we have cosine of 2 theta. On the other side, we have sine with the square, but of ordinary theta, theta. Do we have any formula or formulas? Sometimes we can have several formulas and we need to choose just one, which will be the most appropriate, which can be used to get rid of, let's say, 2 theta, and to convert that left side's expression into something carrying just theta. I'm asking you, I will help you a little bit. Is it cosine of double angle on the left?
Mm-hmm.
How many formulas do we have for cosine of double angle?
3.
Right. One is formula number 2, another is formula number 3, and finally formula number 4. You have 3 formulas, 3, not 1. When it is just 1, we have no choice. But here we need to choose one of them. We cannot apply 3 formulas at the same time. Which one would you choose? Number 2, number 3, and number 4. And please just justify why you did that. Okay, I'm listening.
Is it 3?
You said 3, but I heard some funny intonation in your answer. It was like a mixture of the a statement and a question at the same time. Is it true?
Yeah.
No, it is absolutely normal. It is absolutely normal, and it happens quite often when we work with math. So don't worry. But can you please, dear Jessica, can you please justify why you said why you choose number 3?
I chose 3 because it looks similar to the right side, except instead of 1, it's
But
2.
when you say looks similar, what do you mean?
Oh, the 2 sine squared theta matches on the equation.
Because you saw again what? Sine, you sine squared theta, right?
Yeah.
Yes, this is correct. And this is correct because basically she caught 2 birds with 1 hand. Because not only in this formula on the right, and I'm talking about formula number 3, we are replacing cosine of 2 theta by something which has theta. This is 1 bird. And second, she discovered there same function which she had on the other side. So because here you can have and cosine together with sine as in formula number 2. And you can have just cosine squared like in formula number 4. And you could have something just with sine and sine theta. Yes, this is what it was very wise to choose that particular formula. So let's replace cosine of 2 theta by what it is equal to from that formula. So it will be 1 minus 2 sine squared theta. And copy what you had on the right side. 2 minus 2 sine squared theta. And let's say now what we have looks like 1 minus 2 sine squared theta and equals to 2 minus 2 sine squared theta. Let's separate numbers from trigonometric functions. Now it is up to you. You can collect trigonometric expressions on the left, numbers on the right, or vice versa. What do you want? Sine squared on the left or on the right? Guys, please, quickly, it doesn't matter. Excuse me?
Left.
On the left. This why I'm going to move that from the right to the left, but I will move that 1 from left to the right. Don't forget, you need to change signs. So it will be negative 2 sine squared, which I had already. I am moving that one from the right to left. It will be positive 2 sine squared theta equals 2 was here, and I'm moving 1 to the right. And this what I got. And look what you have on the left. Are they opposite terms? They carry same thetas, they carry same second power of sine, but one coefficient is negative 2, another is positive 2. Can we cancel them?
Yes.
Okay. If we cancel, what are we left with on the left?
2 minus 1. 1.
Is it 0?
Oh.
I'm talking about the left side.
0. Yes.
And this is what I'm receiving because 2 minus 1 is 1. I'm getting 0 is equal to 1. Does it look normal to you that 0 is equal to 1?
No.
Because theta disappeared, sine disappeared with theta, and we are left with 0 equal to 1. This is the nonsense. Please, in parentheses, place capital F, which is the abbreviation for false. And you can face this type of actually problems where you are getting that kind of ridiculous statement that 0 is equal to 1 or 5 is equal to 7. It happens in math. But how should we finish our problem? Please below that write no solution. Not all the time equations have solutions. It happens rarely, but it happens in mathematics. If you do not want to write a sentence like no solution, which is absolutely normal, you can write theta belongs to the empty set, which is this circle crossed out. This I am providing right here on this paper in parentheses. Theta belongs to that empty set. It is an international mathematical symbol, and it means no solution. Did you understand the process?
Yes.
Just one person understood?
Yeah.
Yeah.
Yes. Yeah.
Would you like to move to another problem?
Yes.
Which one would you choose? 71, 72?
72.
72, okay, 72. Sine of 2 theta equals cosine theta. Don't forget to write that theta also should be from specific interval. It is from 0 to 2 pi. It is really important. Theta belongs to 0. At 0, you have a bracket. At that end, at the end with 2 pi, you have round parentheses, which means 0 is included, 2 pi is not. Okay, same questions. Do we have same angles on the left and the right?
No.
No. Do we have any trigonometric formula which can help us to get rid of sine of 2 theta?
Yes.
Help me with that formula, please. I'm going to write. Please dictate me what to write. Is it Demeter?
Yes.
Okay, go ahead, Demeter.
Is it the first formula?
Absolutely correct. And can you tell me what I need to write, please?
Sine 2 theta equals 2 sine theta times cosine theta.
Thank you very much. Awesome. Thank you. I deeply appreciate your help. Yeah, this is what I did. I replaced sine of 2 theta. According to formula number 1, I could do that. Writing down 2 sine theta times cosine theta equals to cosine theta. And now, again, I'm asking that question. Do we have same angles on left and right sides?
Yes.
Do you said yes? Do you see any matching actually functions on left and right?
Cosine theta.
Cosine of theta here, cosine of theta there, right? Are they matching?
Yeah.
Yes. Now it means we got much better form. But how should I continue? Please move that single cosine theta from right to left. Don't forget to change its sign for opposite. So 2 sine theta, cosine theta, minus cosine theta equals to 0. And now look at the first term here. It is 2 sine theta, cosine theta. Second term is just single cosine theta. But the first term, pieces are multiplied by each other. 2 times sine theta times cosine theta. Can I say that cosine theta for term number 1 and term number 2 is common factor?
Yes.
Factor it out. Use so-called Gcf factoring, which means greatest common factor factorization. Move it out of parentheses. So what is left inside? 2 sine theta minus 1 equals to 0. And look what happened right now. We have right now 2 pieces multiplied by each other. One piece is cosine theta. The second piece is in that parenthesis, and their product is equal to 0. If your product is equal to 0, it means that each component, in other words, a factor, because when we multiply expressions or numbers, we call them factors, and the result of multiplication is a product. Product is equal to 0. Each of these factors can be separately equal to 0. So part A, cosine theta is 0. Part B, 2 sine theta minus 1 equals to 0, which means 2 sine theta equals to 1. And if you divide both sides by 2, you are getting sine theta equals to 1/2. I will show this right now to you. Cosine theta is equal to 0 in part A. And finally, in part B, what we see is sine theta equals to 1/2. It means that we now, instead of one piece, as we had on this previous line when it was product equal to 0, we now have 2 separately standing small trigonometric equations. In first one, cosine theta is equal to 0, and we need to find all angles from the first revolution. And in the second part, for the angle theta, sine is equal to 1/2. So right now, we need to solve separately each of these equations. I'm starting with part A. I will sketch small circle. You know, we did it all the time. This is the unit trigonometric circle. And in this circle, I like to show all angles because this one circle represents one revolution, which is equivalent to interval from 0 to 2 pi. In this circle, please name me all angles for which cosine will be equal to 0. Please.
90 degrees.
But we are doing, no, you are correct.
Pi over 2.
Perfect. So, and I'm showing that angle. Is it the only one or we have another one?
3 pi over 2.
Absolutely, yes. I even showed this too in that circle. This smaller one in the first quadrant, as a border of the first quadrant, it is pi over 2. And I'm writing theta 1 is pi over 2. Theta 2 is 3 pi over 2. And I'm done with part A. This, what you told me to write, and I did it. Pi over 2 and 3 pi over 2. I cannot find any other because we are limited by one revolution, right? Part B, I need to find angles for which sine is equal to 1/2. Do you remember that sine is affiliated with y coordinate?
Mm-hmm.
So sketch that circle. Oh my God, my circle looks like an egg. So on the y-axis in this circle, find the point right in the middle of the radius, which has y equal to 1/2. You can see the dot, which I placed. Can you see my circle looks like a perfect egg? It looks so funny. And extend that horizontal line until you cross that circle. And I have 2 points right now on that circle, and connect these 2 points with the center and show 2 angles. One will be in the first quadrant, second will be in the second quadrant. And let's find both. In the first quadrant, which angle has sine equal to 1/2?
Pi over 6.
Right, write down theta 3, because it is already the third theta value in the row, is pi over 6. But I'm left with another one, which is in the second quadrant. Can I say that it is pi minus that small angle?
Mm-hmm.
And what is the size of that small angle? What would be the, because it is a reference angle, is it also pi over 6?
Mm-hmm.
So it will be pi minus pi over 6. And if you subtract pi over 6 from pi, which is 6 pi over 6, is it 5 pi over 6?
Mm-hmm.
So that's it. And you found all angles also for which sine is equal to 1/2. The only one step is left. Now you need to write the solution set. Solution set is, start with the smallest angle to list them in increasing, ascending order. As you can see from comparing that theta 1, theta 2, theta 3, theta 4, the smallest angle is pi over 6. The next angle, you can look even at these circles according to what we see here. Is it pi over 2?
Mm-hmm.
Put comma again. What is the next angle? Is it 5 pi over 6?
Mm-hmm.
And the last one, the biggest one, is it 3 pi over 2?
Yeah.
That's it. Your solution set has 4 angles, which means that equation has 4 solutions, 4 answers. Pi over 6, pi over 2, 5 pi over 6, and finally 3 pi over 2. This is how we solve these problems. Please tell me if you are okay with that problem. So in this case, I will try to solve another one.
Okay.
You know what? I will make right now just verbal recommendations. And I've tried to move back to page 237 to solve some problems from that page. Look precisely, for example, at problem number 73. 73. What do you see here? Do you see here sine of 2 theta and sine of 4 theta?
Yeah.
Yes.
Can I say that 4 theta is a double angle with respect to 2 theta?
Yes.
So I would apply, if I were you, formula of double sine of double angle for sine of 4 theta. You can even write right now my recommendation here. I would treat sine of 4 theta like 2 times sine of 2 theta times cosine of 2 theta. And finally, I would also factor out sine of 2 theta, and the solution will be similar to what we did in problem number 72. Only instead of theta, you will be having 2 theta. If I were you, in problem number 74, you can see cosine of 4 theta. I would do the same thing. I would treat cosine of 4 theta like cosine of double angle, because 4 theta is 2 times greater than 2 theta. So 2 theta is a half angle for 4 theta. What would I use here? be careful. Cosine has 3 formulas, but I already have here cosine of 2 theta. So for this case, I would use formula number 4. Formula number 4 for cosine of double angle. In this case, I would replace cosine of 4 theta by 2 cosine square of 2 theta minus 1, and I will get a quadratic equation with respect to cosine of 2 theta. First, solve this as a quadratic equation to find cosine of 2 theta, and if you know cosine of 2 theta, use trigonometry to find your answers, and so on. For example, in problem number 75, which has sine of theta, cosine of 2 theta, I would use formula number 3 for cosine of 2 theta. In this case, you also will get a quadratic equation with respect to sine of theta, which you can solve, and etc. So in problem 76, when we have cosine of 2 theta and cosine of theta, I would use formula number 4, because I can treat again cosine of theta as cosine of ordinary angle, and cosine of 2 theta is a cosine of double angle. So, and so on. For tangent of 2 theta here, you can replace tangent of 2 theta, and you have here sine theta. I would first treat this like, for example, right here, sine of 2 theta over cosine of 2 theta, and I would replace the top sine of 2 theta by 2 cosine of 2 cosine of theta times sine theta, would factor 2 sine theta out, and etc. So it is difficult, but would just do everything verbally. But this means that quite critically look at both sides to see which formula is more beneficial than others. Now I need to switch to another piece of paper because I don't have any space left here. Can I move to another paper?
Yeah.
Okay. Let me remove these papers. Yes, I am ready. And now I'm back to page number 237. And let's say I'm trying to solve right now problem number 20. So page 237, problem number 20. Number 20. Use the half angle formulas to find the exact value of each expression. And what do we have here? We have cosine of 22.5 degrees. This is what we have. Cosine of 22.5 degrees. And request here was use formulas for half angle in trigonometry. So which means that 22.5 degrees is a half angle of the certain angle. Okay, and I'm going to write this on the side. 22.5 degrees equal to 1/2 of what angle? Just simply multiply 22.5 by 2 to get that angle. Is it 1/2 of 45 degrees?
Yes.
And I wrote here on the side. I wrote this on the side to show that this is a half angle of 45 degrees. So which means I need to use here a formula for cosine of alpha over 2. Can I apply formula number 10b? Guys, can you look? 10b.
Yes.
But can you see it has a radical, and in front of radical you see plus minus?
Yeah.
You should choose or plus or minus. How? Look at this given angle, 22.5 degrees. What is the location for that angle? First quadrant, second, third, fourth?
First quadrant.
Yes, Bhaktima. And in the first quadrant, cosine is positive or negative?
Positive.
That's it. Choose plus. You don't need to, you are not obligated to write plus, but I purposely did that to put emphasis. And now I'm using that formula that it will be on the top, 1 plus cosine alpha. For us, alpha is 45 degrees, divided by 2. And voila, I have much better now expression because 45 degrees or pi over 4 is our one of reference angles, and we need to know this value. And I'm going to proceed. It will be square root 1 plus, what is the value of cosine of 45 degrees, ladies and gentlemen? You need to know that.
Square root 2 over 2.
Yep. And look what I did. Can you see? I replaced that cosine of 45 by its value. And now I don't have any trigonometry. I have pure algebra left. And let's now apply algebra to finish that problem. So I put an equal sign and I'm going to do that simplifications. On the top, you have 1, but you have a fraction. What would be LCD for the top part? Is it 2?
2.
Yep.
In this case, should I treat 1 like 2 over 2?
Mm-hmm.
So which means it will be, I'm going to, I wrote this in bigger size so you will see what I am doing. This, I'm using just pure algebra. Oops. Can you see?
Mm-hmm.
Now, what I have, this fraction on the top should be divided by 2. Okay. I'm going to replace this by the multiplication by the reciprocal. Dividing by 2 is same thing like multiplying by what? By 1/2?
Yeah.
Okay, so. And 1/2 times 1/2, is it 1/4?
Yeah.
Yep.
So I'm just using algebraic steps to simplify. Now I have a square root of the fraction. On the bottom I have 4, which is great. Square root of 4, is it 2? Guys, you do not know that square root of 4 is 2?
Yeah.
Definitely yes. You know what? This is your exact answer. It does not look very attractive, but we have what we have. Just box it. This is your answer. They wanted to get an exact answer. Voila, we are providing our exact answer. Which one do you want? 21, 22? Guys. 21 or 22 on that page?
22.
22. What do we have in 22? I try to solve as many problems as I can because we need to be in a hurry already. Tangent of 9 pi over 8. 9 pi over 8. And here I will have a little bit more steps because I really do not like this 9 pi over 8. But 9 pi over 8, is it 8 pi plus 1 pi over 8?
Mm-hmm.
Let's do that. We used this trick so often before. Okay, so voila. And I will break this into two pieces. 8 pi over 8 is pi. And now, instead of that, I have tangent of pi plus pi over 8. And now I will simplify that. You can simplify this already in many different ways because you have a formula for tangent of alpha plus beta, tangent of the sum of two angles. One angle is pi, another is pi over 8, but it can be done easier. So, which means first method, you can apply tangent of alpha plus beta to simplify that. But it is not the best way. It is correct, but not the best. Second, do we know that tangent is pi periodic function?
Hmm?
So which means you can drop this pi or any multiple of pi. Second method, which is very elegant. The third method is our European method when we say, oh, pi plus pi over 8 is in the third quadrant.
Yep.
In the third quadrant, tangent is positive. So it will be positive. Now this pi, is it the horizontal quadrantal angle?
Yes.
Which means you can keep the same tangent, not changing the name of the function. So it will be positive. It is in the third quadrant. Because of that, it is positive. We have here in parentheses horizontal quadrantal angle pi, which means we keep the same tangent. Reference angle is pi over 8. Which method would you like to use? Number 1, number 2, or number 3?
The pi periodic one.
And I would choose the same thing because it is the shortest. So drop that pi. So, and you are left with tangent of pi over 8. Now you have tangent, definitely, as a result of all these methods, number 1, number 2, or number 3, you will get the same thing. And now up to you. Why? Pi over 8. Pi over 8. Is it 1/2 of pi over 4?
Yeah.
So which means we can treat pi over 8 like half angle, for which pi over 4 will be an ordinary angle, 2 times greater than pi over 8. So you can use several formulas, and pi over 8 definitely, which is half of pi over 4, is from the first quadrant. So if you like, you can use formula number 10c, where you will get positive sign, square root. It will be 1 minus cosine of pi over 4 over 1 plus cosine of pi over 4, and use algebra to proceed. But there is even better form. Look at the formula number 11. There are 2 formulas for number 11. It will be even easier because here we do not have a root. You can use first version or the second version. Which one would you like to use? 1 minus cosine alpha over sine alpha, or sine alpha over 1 plus cosine alpha?
1.
I could not hear.
1 first.
The first one? Okay, but if you like, you can choose the second one. In this case, if you use the first version, write down that tangent of pi over 8 equals 1 minus cosine of pi over 4 over sine of pi over 4. This is from formulas number 11. And instead of pi over 4, we have 1 minus square root of 2 over 2. And on the bottom, we also have square root of 2 over 2. And proceed, which will be on the top 2 in denominator. On the top of that will be 2 minus square root of 2. On the bottom, you have square root of 2 over 2. We have fraction divided by another fraction. We will replace it by 2 minus square root of 2 over 2 times reciprocal of the bottom fraction. You don't have 4 levels anymore. You can cross out 2 2's, and you are getting 2 minus square root of 2 over square root of 2. But because you have that square root of 2 in denominator and you like to get rid of that, we will be multiplying top and the bottom by square root of 2 over square root of 2. Which will be on the bottom, square root of 2 times square root of 2 is square root of 4, which is 2. Or you can say square root of 2 times square root of 2, it is square root of 2 squared, which also gives you just 2. On the top, you have 2 square root of 2 minus square root of 2 again times square root of 2 is 2. We have here so many 2's now. We need to simplify. We cannot keep it as an answer in algebra because your answer should be in the simplest form. On the top, I am factoring out 2. So, and I am getting here 2 outside of parentheses. In parentheses, square root of 2 minus 1 divided by 2. And now I can cancel both 2's on the top and on the bottom. And I'm getting my answer, square root of 2 minus 1, or if you like, negative 1 plus. I like to start with the positive at the beginning. This is your answer.
Can you raise it a little higher, please? Okay, thank you.
Mm-hmm. Did you understand?
Yeah.
Did you understand the process?
Mm-hmm.
Again, we used lots of algebra today. Honestly, I feel that I showed enough examples here for all this section. So, and I will be definitely next time covering another section. But now I am stopping, and please, right now, write that coordinates of that quiz. It will be quiz number 4 dash INC. These are coordinates of that quiz. Quiz number 4 dash INC. This is quiz number 4 in class. And please go to my math lab right now and take this quiz, and your time will be actually up to 12. If you like, if you finish earlier, you are welcome to do that. So this why you need to leave me right now. Actually, I will be here on Zoom. If some of you finish it earlier, you can come back and talk to me asking some questions. But please, all others, quickly go to my math lab and start solving these problems. And this is from quiz number 4 dash INC. Did you write down this quiz number?
Yes.
Mm-hmm.
Please, right now, don't waste your time. Go right now. There are 5 problems, not difficult, waiting for you there. And I'm not going to check attendance because I will see everything on as a result of that quiz. Okay. Everyone, good luck. Guys, don't stay here on this screen. Go to my math lab, please. Back, Tima.